Welcome now to our last lecture on measures of association. So we've done cohort studies, we've done absolute risks, attributable risks and relative risks, we've done case control studies, and so now we're completing off the last measure of association, the odds ratios. Please note the last textbook reference and the questions, the textbook questions, those questions are applicable to all of the risks, attributable risks, relative risks, and odds ratios. And again, these objectives are similar to what you saw in the other two measures of association lectures, except that this is specific to odds ratios. So remember this dichotomous classification between our exposure and our outcome that we saw in the last two risk measures of association lectures. Again, we're going to see this again and again, and is useful for both cohort and case control studies when we're comparing a risk. Remember, in the cohort study, we had participants had been divided into two groups depending on their exposure. And so these groups were represented by groups A and B, so the exposure. And the non-exposed group, which was our control groups, were represented by groups C and D. Then cases emerged naturally over time in the exposed group. So these were the cases that occurred naturally over time in the exposed group, and also our percentage of cases in our non-exposed group. Then we were able to gather all this information to provide appropriate numerators and denominators to calculate the incidence of disease. Remember that we looked at the basic expression of risk was incidence, and absolute risk, attributable risk, relative risk, we're all able to use these components. And so essentially we were able to work out the disease in the exposed group, so the incidence in the exposed group. We were then able to compare this with the incidence in the unexposed group. And of course you will recognize the calculation. We were then able to plug all these numbers together to give us the relative risk. So that's where we've come from. The case control study, on the other hand, begins with the selection of the group of cases, A and C, and the group of controls, B and D. So unlike the cohort study, which selects this way on exposure, the case control study selects this way on outcome. Therefore, there is no way of knowing the rate, because the groups are determined not by nature, but by the investigator's selection criteria. Therefore, it is not possible to compute or calculate the incidence of disease among the exposed or unexposed groups, which means we cannot calculate relative risk in a case control study. What this means, however, is that we look at the relative frequency of the exposure between the cases and controls. So we say that in the case group, the exposure occurred this much, and in the control group, the exposure occurred this much. One approach to comparing the frequency among cases and controls that provides a measure of risk that is both conceptually and mathematically similar to relative risk is the use of the odds ratio. And the odds ratio is defined as the odds that a case is exposed divided by the odds that a control is exposed. But let's just stop for a minute, because what do we mean by odds? The odds that a case is exposed versus the odds that are controlled. What are odds? This is just a little refresher. So odds is the ratio of success to failure, which is it is the proportion that the event does happen divided by the proportion that the event doesn't happen. So an example here is that probability is that 1 out of every 5 times means that 1 time in every 5 is a probability example. An odds example is that 1 out of 4. So there's still 5 times. So there's a total of 5 times in the first example. There's still 5 times in the second example, except 1 time the event occurs and 4 times the event doesn't. And that is an odds. You can have a little bit more of a look about definitions of odds. If you want, go and have a look on Wikipedia or some statistical websites to make sure you're really comfortable with what we talk about when we talk about probability versus the concept of odds. Let's go back to looking at how we actually calculate our odds ratio. So remember, because of the way we select for outcome, we can't actually determine the rate between the exposure and the outcome, that direct link. So we're looking at the frequency of an exposure between the cases and controls. And so that looks something like this. So it's a calculation of the exposed plus disease divided by all who have the disease, divided by those not exposed with the disease over all of those who have the disease. That's the top. So that's the outcome, all those with the outcome, divided by those exposed without disease over everyone without the disease, divided by those without the disease who aren't exposed over everyone without the disease. And if that is a little bit of a mouthful, looks like it should be a mouthful, we can break that down to look like this. So it's those exposed with the outcome divided by those not exposed but with the outcome, all divided by those without the outcome but exposed, divided by those not exposed and not without the outcome. So again, we're breaking it down to look at the relative frequency between the exposure and disease. How many more times or how many times less does the exposure occur in the cases compared to the control groups? Further breaking that formula down, this is just all the mathematical breaking down, is we can break it down into AD divided by BC. And that is a very simple formula for odds ratio. So don't worry too much about the derivation of the formula. What is really worth remembering is this. I'm not going to ask you to derive the formula in an exam. I just wanted you to see how we get to AD on BC from our dichotomous classification. When we look at the interpretation of the odds ratio, similarly to relative risk, if the frequency of exposure is higher among cases and controls, the odds ratio is greater than 1, indicating an increased risk. The stronger the association, the greater the odds ratio. If the frequency of exposure is lower among cases and controls, then odds ratio is less than 1, and this indicates protection. Often in studies, because of the similarity of the information conveyed by an odds ratio and relative risk, odds ratios can often be reported as an estimated relative risk. So it's just another terminology for that. Let's look at the relationship between relative risk and odds ratio. The odds ratio is approximately equal to the relative risk when the incidence of disease is low. You'll note here that I've got that it's typically less than 10%. But really, it depends on the size of the relative risk to actually determine how low the incidence must be before your odds ratios is approximately equal to your relative risk. Here's my example that I've used in the other measures of association lectures, and you can have a go calculating odds ratios using the numbers that we learnt to plug into the dichotomous table in the last lectures. and I'll leave you to have a look at the answers when that suits you. Just as a reminder that we talked about using the 4 components when reporting risk. You need to include the exposed group, the unexposed group, the risk, and the outcome. Only note for odds ratios that instead of saying the relative risk, we say the odds of. Just something to keep in mind that odds is not an easy concept. You probably know that through just getting your head around working with odds instead of probabilities. People who interact with the gambling sector a lot have a better idea of it, but generally when communicating to your patients, it's not a good idea to communicate in odds because it's not something that is used very frequently and commonly in our society. So you'll need to interpret anything that comes out of a odds ratio into something that is more appropriate for communication with your patients. That brings us to the end of the measures of association, including odds ratios. Until next time, thanks very much.